Alright, testing. Chapter 3, Section 3. Chapter 12, Section 3, Metallizing. General. Metallizing uses the spray metal coating with a fabricated workplace coating metal initially with a wire with a power form fed with a special gun melted with the oxy-fuel gas flame, atomized by a blast of compressed air with the air combustion gas transport, atomized molten metal on the prepared surface where the coating is formed. Show the wire metallizing process, oxy-map, compressed air, flame, gas, metal, and wire burning air envelope, air cap, wire, not gas nozzle, atomizing spray, sprayed metal, prepared base. Metallizing process of the welding spray gun that enable the weld of the processively matches little with the weld metal is necessary, often desired for the surface metal deposit of 3,000 of an inch to any of the desired thickness. May be made the process versatile, time saving in some cases more economical than other welding repair procedures. Metal coatings are used to repair worn coating with a salvage machine component that provides special compartments to surface with the original equipment. The metallized coating are used to improve the strength of the adhering, adding corrosion, heavy heat resistant, hard facing, increasing lubricity, and improving thermal and electrical conductivity, producing decorative coatings, corrosions resistant. Coatings are aluminum, zinc, and are applied with a ship hull of the bridge of the storage tank with the canal gates. For example, the hard facing and applied with the shafting of the gear teeth over the other machines as well, with the mining of the equipment over the chute of the hopper track for the rails, coating with the combined bearings. Lubricacity properties are used to improve the surface life of the machining shafting and slides away. The characteristic coated surface with chemical properties of sprayed coatings are those of the coating metal, but the physical properties are often quite different. The table 12.2. The sprayed metal coatings are not homogeneous. The first molten droplet metal gun will hit the substrate with a flat out, with the subsequent particles with the overlay with the first deposit of the building of the porous laminar coating, bonding essentially mechanically, although some metallurgical bonds also may occur. These small pores of the droplets soon have been clothed with the coating, and the thickness of the microscopic pore of the and can hold lubricants of one over the region of the mechanized coating of the increased lubricacity of the wear surface. The tensile strength of the spray coating of the high of the relatively low melting point metals used. The ductility is uniformly low, therefore must be with the formal first of the then spray with this coating with a low melting point metals such as sprayed in zinc on steel with a manner exemption of this rule that can withstand limited forming. Your workpiece restriction. Metallizing is not limited to any particular size of the workpiece. The work may vary from with crane boom with electrical contact. Metallizing may be done on the production line by hand in the plant or in the field of the workpiece. Workpiece geometry has important influences on the process of the cylindrical parts of the shaft of the driver of the press roll that can be rotated in the lap of the fixture of the ideal spring with a machine mount with a gun. For example, the metallizing gun can be mounted on the carriage of the lath of the spring and the workpiece with a predetermined feed rate. The parts of the chest of the cam are usually sprayed by hand. Some of the such parts are sprayed automatically. The cost to elaborate with the setup of the automatic spring may not be justified. Volute, part of the small pump casing of the difficult coating because of the backdraft splashing of the metal spray. Small diameter holes and bores or any depth of the narrow grooves are difficult to impossible to coating because of the bridging of the spray of the coating. Alright, materials and metallizing. A wide range of the materials can be flame sprayed, with the most often include with the metal with the refractory order, oxide with the form of either powder or reds. Also be applied with a flame spraying. Include the entire range of alloys and metals, from lead, which melts at 618 degrees Fahrenheit, the molybdenum melting point of 4,730 degrees. Higher melting point with it can also be sprayed with a plasma arc spraying gun is required. Between the extreme of the lead with the molybdenum, the common the metal coating with the zinc and alloy, zinc and aluminum, tin, copper, the various brasses, browns, carbon steel with the stainless steel with the nickel, chromium, and alloy spray coatings can be combined. On one workpiece, for example, the molybdenum and nickel aluminide, often used in thin coating of the steel parts with increase the bond strength, and another coating metal is applied to build up the deposit. Surface preparation. Surface of the for metallizing must be clean. They also have to require roughing to ensure the good mechanical bond between the work surface of the coating. Grease and the oil with the other contaminants were rearmed with suitable salt of the cast iron and other reinforcement metals should be preheated to 500-800 degrees Fahrenheit to remove the entrapped oil with the other foreign material with the sandblasting. Maybe should be used to remove the excessive carbon resulting from preheating cast iron. Chemical cleaning would also be necessary prior to the preheating and undercutting off the necessary with the on the shaft, the cylinder shaft, the permit uniformly with a thick ability of the finished part with the depth of the undercutting depends on the diameter of the shaft and surface of the requirements of the undercut of the surface that becomes oxidized and coated. Laminated, they should be cleaned before roughing and the spraying. The roughing, the workpiece surface is usually a final step before spraying the various methods of arranging for roughing, threading, and the threading of the knurling and abrasive blasting and electrical blinding. Molybdenum and nickel aluminum spray castings applied with the roughening surface to improve the bond and strength of the subsequent coating of the application that require only thin coating of the sprayed metal with the only other eliminating roughening step that go directly with the bond and coating surface and build up with some other metal. Alright, your coating thickness. Cost surface requirements are basically determined with the practical maximum coating thickness of the particular application, such as the building up of the warm machine part. Total mechanism costs include the cost of the preparation, oxygen, fuel, gas, material for the application time. The finished operation that the repair costs are the two half of the more economical to buy the replacement part. Total thickness of the as sprayed coating of the shaft that determines the maximum year aligned with the minimum coating thickness must be sprayed with the amount of stock required to finish the operation. Minimum coating of the thickness that must be sprayed depends on the diameter of the shaft. Is given with the table of 12.3, page 1210. And for the press fittings, regardless of the diameter of minimum of the 5,000 of the coating is required. Alright, variation in thickness depends on the type of the surface preparation. The thickness of the deposit over the threaded surface varies more than those of the deposit over the abrasive blasted surface. The smooth surface prepared with a spray bonding with a general with the total variation thickness can be expected of routine production spraying with a normal mounted equivalent of the 2,000 inch for the deposit of the metallizing wire. Alright, coating shrinkage. The shrinkage of the metal deposit almost must be taken into consideration and an effect for the thickness for the final deposit. For example, the position of the inside diameters must be held at a minimum thickness for the form of the shrinkage test. Stress coating excessive thickness for the separate with the workpiece will become excessive stress and inadequate bond strength. Table 12.4 with the give the shrinkage value of the metal with the commonly used for the spray with the coating with the thin coatings can be deposited with the metal with lower shrinkage. All spray metal coating is stressed with the attention with some of the degree except within those with the substrate material with high efficiency with the expansion is in the preheated approximate temperature for the spraying of the stress with the can cause the cracking of the thick metal with the coating with a high shrinkage value with the austenitic stainless steels as the category. Alright, the suspected of the cracking with the thick austenitic stainless steel that can be prevented by first spraying with a martistic stainless steel with deposit on the substrate with the depositing authentic stainless steel to obtain required coating thickness of the martistic stainless steel produce the stronger bond with a substrate with a good strength as a sprayed form that provides the excellent surface of the authentic stainless steel. Alright, your types of the metallizing, electric arc spraying, or EASP. Electric arc spraying with a thermal spraying process of the use of the electric arc between the two consuming electrodes, surface of the material with the heat, source of the compressed gas, atomized with the propel of the molten material to the workpiece. The principle of the process is shown in figure 12.3 with the two consumable electrodes. Wires are fed with the wire feed to bring it together with the angle of the approximate 30 degrees to maintain an arc between them. Compressed air jet is located behind the directly lined with the intersecting wires. The wires melt within the arc of the jetting. The atomizing the melted metal propels the fine metal particle with the workpiece. The porous source of the producing arc with a direct current with a constant voltage welding machine. The wire feed is similar, but it can be used for the gas metal arc welding, except with that in the feed two wire with the gun can be held with the holding of the movement. A mechanism of the part with the gun is moved with respect to the other and provided with the coating surface of this part. Figure 12.3 shows the electric arc spraying process, compressed air with a power source of the spray metal, electric arc, and atomized and base material. Alright, generally, the welding current ranges from 300 to 500 amp, the direct current with the voltage range from 25 to 35 volts. The system will deposit 15 to 100 pounds per hour of the metal with the metal deposit depends on the current level of the type of the metal being sprayed. Wire spraying the side according to the brown and sharp wire gauge system with normally either 14 gauge or 11 gauge is fused. Large diameters wires can be used. The higher temperature for the arc of the metals of the electrode wire fed for the deposit, particularly having higher height content, greater fluidity within flame with the spraying process with the deposition rate with the 3 for the 5 times greater with the bond strength with the greater with the decoherency with addition with the mechanical bonding of the deposit, more dense coating strength with the greater than the flaming spray. Flaming spray. The dry compressed air with the atomizing propelling with the molten metal pressure of 80 psi and 30 to 80 cubic feet a minute. The cubic is used. Almost on any metal that can be drawn, the wire spray with the following of the metals that are arc spray that are aluminum, babbitt, brass, browns, copper, molybdenum, mono, nickel, stainless steel, carbon steel, tin, and zinc. Alright, your flame spraying. FLSP. Flame spraying and thermal spraying with the process of the oxide fuel with the gas flame. A source of heat melted and coating of the material with the compressed air, with usually atomizing with the propelling the material through the workpiece. There are two variations. One uses metal of the wire form, and the other material of the power form. The method with the flame spray with the U of the power uses powder and sometimes known as the power flame spray. The method of flame spraying with usually using wires known as metallizing in the wire flame spray. Spraying. In both versions, the material is fed with a gun and nozzle that melts with the oxygen fuel gas flame, and the atomizer the required the dome and the air jet with which propel the atomized particle to do the workpiece. The wires used in the ceramic material and fed with the nozzle with the air jet with the wire feed is and melted with the gas flame with the power source. Powdered materials are used and that may be fed with the gravity with the hopper, which is part of the gun, and another system of the power of the picked up with the oxygen fuel gas mixture carried with through the gun where they are melted and propelled to the surface of the workpiece of the flare. Figure 12, foreshape of the flame spray process with the use of wire. The version with the use of wire with the spray metal that can be prepared in a wire form. The variation, the use of the powder, ability to vary various materials that include the normal metal alloys, oxidation, resonant metals, and alloys and ceramics to provide with a sprayed surface many different characteristics. Alright, your plasma spraying. PSP, plasma spraying, thermal spraying process, which uses the non-transferred arc with the source of the heating of the melting process, melting and propelling the surface of the material of the workpiece. The process shown for 12 and 5. 12 force of the flame spray process with compressed fuel gas, wire, flame cones, burning gas, air envelope, sprayed, atomized spray, base as plasma spray, DC power, circulating coolant, plasma gas, calculating electrode, spray powder, carrier, gas arc, nozzle, plasma flame, sprayed materials, spray stream base. Metal. In the process, sometimes called plasma flame spraying or plasma metallizing, using plasma arc, which entirely with this plasma spray gun with this energy that is much more higher than the arc spray and the flame spray with additional materials that can be used with the coating of the more inorganic materials which will melt. Decomposition can be used. Material must be used in a powder form. It is carried with the plasma spray gun suspended into the gas. And high temperature plasma immediately melts the powered material and propels it to the surface of the workpiece. Inert gas, extra high temperatures are used. The mechanical metallurgical properties of the coatings are generally superior with either flame spraying, electrical arc spraying, including the reduced porosity, improved bond, and the tensile strength of the coating density. They can each reach 95%. Hardest metals known with some which extremely high melting temperatures can be sprayed with the plasma spraying process. Alright, the spraying operation. Spraying should be done with intermediately after the part of the clean. The part is not sprayed immediately. It should be protected by the atmosphere with the wrapping it with a paper. The part is extremely large, maybe the necessary with the preheat with the part to 200-400 degrees Fahrenheit. Care must be extra with the heat. It does not build up the workpiece. Increase the possibility of the cracking with the spray. Surface the part with the coated with the preheat with the approximate temperature for the normally with it. Same with during the spraying operation. The distance between the spray gun and the run part dependent on the porosity of the material that is being sprayed. The recommendation of the equipment the manufacturer should be followed with a modified experiment with the speed and feed with the spray should be uniform. The first pass should be applied with quickly as possible. The addition with the coat with it may be applied slowly. It's important to maintain uniformity temperature throughout the part when there are areas of the part that being sprayed with the coating is not wanted. The area can be protected by masking it with tape. Tools and equipment. The major items. The equipment of the process for the consumption with the Udic torch and a few fittings are the same. The normal oxy-settling well with the cutting torch. The oxy-settling cylinder regulator, fittings of the pressure regulators, hose, striker's torch, the regulator wrench, tip of cleaners, goggles, and same as over the common use in welders, metallizing and the welding torch accessory tip of the Y and a Y hosing fitting of a distinct with a piece of the equipment used in metallizing. Alright, metallizing with a welding torch. The torch is manually operated with the power dispersing the oxy-settling torch with the 3-section torch body of the mixing chamber. The valve assembly on the tip of the assembly. These assemblies are chrome plated with a prolonged surface life to prevent the corrosion of the contamination. Torch body is also a handle like a body of the regular welding torch that has a needle valve with the control of the flow of the oxygen. Settling the mixing chamber with the valve with the assembly heart of the torch for the dissection of the flow of the powder of the oxygen streams and controlled mixing takes place with lever like of the cutting lever on the torch of the control flows the powder of the metal with the level down with the powder flows with the release powder flow and it is shut off of the valve plunger and made plastic should also be blockage Outer curve with no sharp rough objects should be used to clean it occasionally, but the material will build up inside of the bore. Cut down the operation efficiency. Any malfunctions occurs or suspected in the bore. First item, check with the just forward of the feed level. The connection attaching the power bellows and modules must be in the up position while operating. Tip assembly is made with a low heat conduct alloy. It can be rotated with locked in any position angle with a 0 to 30, 160 degree with axis tips if they're screwed on the end of the assembly. Your accessory, the tips are either the 3 side of the number, 45, 48, and 53, according to the side of the drilled number that you've drilled, or if it's the largest number, the smaller the hole, larger the number, the smaller the hole. The number 45 tip would be used for heavy buildup, while the number 53 tip would be used for fine and delicate work. Wide fitting, the wide fittings provide with a set with one fitting left-hand threads for the acetylene with a connection with the other, right-hand threads for the oxygen connections. These fittings allow with the regular wrench torch to be used in the same tanks for this at the same time metallizing torch. Materials, generally the materials making the welds of the overlay with a little different in form, them not new, but the purpose for filler fluxes used for the hard to weld metal, filler metal in the form of the fine powder, used the weld of the coating material with the two fluxes and the paste used for the combination of all the different powder alloys. One of the fluxes copper alloy, copper only. The other is all types of metal with welding powders. Metal powders are a high-quality special formulation of alloys developed in a wide variety with the job. The job range from the joining of the copper to copper to putting in the hard surface of the gear tooth. Coppering the proper alloy depends on the base metal with the surface required. Powder alloys come in the plastic containment called the bellow module. These are ready to insert the connection on the valve assembly after the stoppers have been removed. 12-12 setup. The equipment of the torch hooked up with the oxygen settling tank with the same manner with a regular working torch. The tip is rotated with the correct angle for the welding position being used, locked in place. Operation. To operate a torch with the correct pressure for the setting of the needed to determine the size of the tip being used. The tip number 45, 48, or use the 25 to 30 psi with the oxygen, 45 psi acetylene tip with the 15 to 18 psi with the oxygen, 2 to 3 psi of the acetylene. After the pressure has been set, the torch is lit and then adjusted with the with the neutral flame with the alloy fed lever to depress the done before joining the module of the torch. After the proper flame adjustment, the module is attached to the torch. This is done by turning the torch upside down and inserting the end of the module into the igniting part of the located of the valve assembly. Twist the right locks of the module in place only with the torch and is held upside down during the loading and unloading. Alright, before applying the powder to the surface, before applying powder to the surface of the joint area of the preheating, the steel is heated with the straw colored white brass coppers are heated with approximately 800 degrees Fahrenheit. After preheating, powder feeder lever the press then cover the powder with the place over the desired lever the surface. The lever is relief on the air with the heated with the powder wet surface. The tinning action takes place on the tinning of this observer. The feed lever is depressed on the layer no more than 1/8 of an inch thick of the deposit. Within more metal desired of the area that should be reheated. Light cover the powder should be applied with the heat again with the tinning of the take place to ensure the proper bonding. In this manner, any of the desired thickness can be obtained with the weld depositing metal. But the torch must be kept with a constant circular motion to avoid overheating of the metal. To shut down with the torch, the same procedure with the valve with the regular welding. Order once the flame is that with the bellows module to remove it and turning the torch upside down and twisting the module to the left. The plug must be replaced and to prevent the contamination of the alloy. 12-14 malfunction corrective action. As with any equipment, if malfunctions can occur, the orifice should be made checked if there's no observable deposit made when the feed lever is depressed. Section 4: Flame cutting steel and cast iron.